Alright, what we have here is Spaceflight Simulator for the Android. And I recently got, my best buddy playing this game. And he's pretty new. And the game doesn't, if you just jump in and play, you can kind of get confused on how exactly to get to, like, the moon or Mars or Venus, Mercury. The game doesn't really go into a whole lot of detail unless you go into the tutorial page, but even then it doesn't tell you a lot. So I decided, you know what, I'll make a video and hopefully I can explain it a little bit better. So what we're going to do is we're going to go to build a rocket, and this rocket's purpose is going to be getting us to the moon. I have here a series of, pre-built rockets that I've made and I've saved the designs for. And you would think, since we're going to the moon, I would use the lunar module model that I made. However, this model isn't very efficient. Why? It's because there's too much weight compared to the amount of thrust that I'm outputting. Okay, this model will get you to the moon, but it is very fuel efficient. So, I use this model, and this model has successfully landed me on the moon and on Venus. I find this model very dependable, very consistent in the things that it does. So, I do have more weight here than the previous lunar module model that I made. However, I have 4 boosters down here at the bottom that I'm going to use to get me outside of Earth's greater gravitational influence. And just for, to simulate safety, I do have my rocket equipped with 2 side parachutes, and then of course the parachute on top of the capsule. I do have the landing gear, and I have another stage kind of in the lower third of my rocket, and a secondary stage which is going to be basically for my lunar landing. So I know you're probably tired of hearing me talk, so let's go ahead and go to the launch. If you look down here, I do have a little bit of debris from playing around with absurd rocket designs. But now you can see here that I've turned on 4 of my engines, and that's going to be engine 1, 2, 4, and 5. Okay, I don't want to turn on engine 3 until I get outside of Earth's greater gravitational influence. I want to set my throttle to 100%, and I want to take off. Now, taking off in itself is a little bit of a science. I want to fly straight up, but not for long. I want to keep this same path until I get to about roughly 1,500 or 2,000 meters. When I get, wrong button. When I get to about 2,000 meters, I want to start adjusting my angle to about roughly 20%. And this is going to give me a parabolic trajectory. This is that line you see here. It kind of forms a bell. And that's what we want. Now, as I go up in my altitude, I want to just keep adjusting my flight angle more. And I want to keep on doing that until I get to about roughly 15 kilometers. When I get to 15 kilometers, I want to start adjusting my angle to where it is roughly 45 degrees. The reason I do this is that way I don't have to fight the air drag of Earth's atmosphere, and it also makes it easier to fight Earth's gravitational influence. And now that I'm outside the sphere of greatest gravitational influence, I want to start running a parallel course to Earth. But let me jettison these and lose a lot of that obsolete weight. So now, as I said before, I want to start kind of running a parallel course to Earth. And what this is going to do, this is going to widen that trajectory. It's going to make a bigger bell. As you can see, it's expanding even more, and I'm still gaining velocity, and that's what I want. And this main rocket stage here will last me through about halfway of gaining an orbit. So I want to keep on following this trend until I create an orbit around Earth. And this part requires patience. It's not always the funnest thing in the world to do. But, you know what? It's worth it. It's a pretty good feeling when you get to land on the moon. As you can see here, I've roughly made half of my orbit. So now I want to jettison that stage and turn this stage on. Now that I've lost a total of about 65 to 70% of my weight, my acceleration is favorable now. And as you can see, I've almost made an orbital ring around the Earth. Right there is where I want it. Now we can look at the positioning of the moon, where it's at. Okay, the moon's right over here. And actually what you can do is you can click on where it says moon, and that will set the moon as a target. Now when I do that, you will see a highlighted ring right here. And this is the optimal prograde burn space. This means this is the best place to start a prograde burn, which means you burn your engines in the direction that your rocket is going. Retrograde is the opposite. That means you burn your engines in the opposite direction of which you are going. But we're going to focus on prograde burns right now. So I want to go ahead and I want to accelerate time a little bit. And I actually don't like that optimal angle there. So I'm going to ignore that. It'll be more fuel efficient right here. So what I'm going to do is I want to aim my rocket in the direction that I'm going. And I want to start a full thrust prograde burn. When I do that, you can see my orbit getting more elliptical. And I want to continue this trend until my orbit overlaps with the orbit of the moon. Okay, I want to just basically get right in its path. Slow it down a little bit because I really want this to be precise. Right there is pretty close. So now what I'm going to do is I'm going to accelerate time now. Had I burned in that, the optimal space in which it wanted me to burn, the highlighted space in my orbit, it would have put me in line with the moon much earlier, but this is much more efficient on fuel. As you can see now, I will be intercepting the moon, and that's what I want. And on the moon, you can already see several other landers that I've landed successfully on the moon. So now this is where it gets a little bit tricky, because I want my intercept path to land directly on the moon. So the way I do that, turned the wrong way. So I want to just burn my engines. Of course, I ran out of fuel. But that's okay. That's why we have this stage. This is what this stage is for. This is a higher efficiency rocket. And this rocket is going to be for landing me on the lunar surface. So now I just want to get my rocket prepared for that. I want to accelerate time just a little bit. And right here I want you to take note of my height and velocity. Right now I'm almost 400 kilometers above the lunar surface at a velocity of 353 meters a second. That is really fast. It's going to be too fast to land. So as we get closer, I'm going to show you how to correct that. Now that we're about 200 kilometers, I want to make sure that I have a stable path set for the lunar landing. And the way I want to do that is I just want to close that bell shape, that parabola. And I want to get that dude as narrow as I can. That looks pretty narrow. I want it just a tad bit narrower. I want to get this pretty precise. Right about there is where I want it. Can't ask for much better than that when you're in a hurry. So now that I'm about 80 kilometers above the moon's surface, I want to start lowering my velocity down because I'm burning pretty hot right now. And I'm going to do that with a retrograde burn cycle. And as I do that, you can see that my velocity is lowering. And I want to get that velocity pretty low. I want to get down here to about 40 kilometers. And that's when I can really start to slow this my craft down. Now what I want to do is I at least want to get my speed to under 200 meters a second. So now that I've done that, I'll accelerate time even more. This is a process. But now that I'm about 10,000 kilometers, I really want to start burning. I want to lose as much of that excessive velocity as I can. And that pretty much does it. I did go a little excessive in slowing down, but that's okay. Because now that I'm under 5,000 meters, that means I really got to mind my P's and Q's here. I want to be able to land this thing rather gently. And it looks like I do have a relatively flat space to land, which is good. So I want to prepare for that landing. I want to go ahead and get my landing gear prepared. And as I drop down, I'm just going to take her nice and easy. Okay, I'm not doing anything with my engines until now. Once I get below 2,000 meters, I really want to try to get my velocity slowed down as much as I can. And that's not very crucial right now, but once we get lower and fairly close to landing, that's when it's really going to matter. Because if you come in too hot, you're going to bust your landing gear and you're just basically going to blow up your lander. So we're just going to come in nice and easy. And once I get to about 500 meters, that's when I'm really going to start to slow this thing down, because that ground can sneak up on you rather quickly. And basically what I want to do here is I want to keep my velocity in the single digits. You can see here just exactly how close I am to that moon. And basically what I did there is I wanted to make sure that my landing was going to be just about as straight up and down as I can get it. I don't want much sideways motion, because that makes for a much difficult landing. So now that I'm getting rather close, I'm just firing short pulses. Whoa, so much for a smooth landing area. So I'm just going to kind of bounce the rocket up until I can find a more favorable spot. Hopefully down at the bottom of this hill. I don't know how long this thing is. I should have looked at that a little better. That seemed like a pretty good place to land back there, so I'm going to try to land right back in there. Whew. And then just boop, lay it down like a brick. There you go. It wasn't necessarily the most graceful landing, but nonetheless we made it on the moon. See, from here it looks pretty flat, but there you go, and that's basically the easiest way that I know to get to the moon.